right, this is for version B. It doesn't change until we get to step 4. So hopefully you have numbers for your 4 launches. I'm looking at the height here. If you add those 4 together, and then it says divide by the number of numbers that you added, so divide by 4, and that will give you your average height. Do the same thing with the distances. Add them all together, divide by 4, and you got your average distance. Of course, if you do that and you notice those averages are not in between all of these numbers, if it's like higher than all of them, you know you did a little bit something wrong, and probably has to do with the order of operations. You're going to want to make sure and do all that adding first, come up with an answer for it, and then divide that whole answer by -4. If you just type into a calculator all at one time, then chances are you're only going to divide the last number by 4, since order of operations tells us to do the division before the addition, and that would get your average to be higher than it really is. So once you have these 2 numbers, the 2 averages, those are what we're going to use to fill in all 3 of those points. So clear things off here, and the vertex first. So the vertex is going to be the middle point of our projectile path, and so in the middle is where the height, where it reaches its heights. And so up and down is controlled by the y coordinate, so we're just going to take that average height and plug it in for the y coordinate of the vertex. The x coordinate controls the side to side, and so we had a distance of 126 in this example. You will certainly have a different number there, and we're going to cut that in half. So we're going to divide it by 2. Once we divide it by 2 to get half of the distance, that'll be right in the middle where our vertex is, and then we can plug that in. I took my 126 divided by 2, I got my 63, and plug in that number right there. The x-intercept is the point where our projectile lands. You see, it's got a y coordinate, so up and down is 0. That means it's on the ground. And then its x coordinate is the full distance. So you're just going to take the average distance, plug it in right there, and you've got your x-intercept. The y-intercept is the starting point. We've got side to side of 0. We have no distance, is what that's saying. And your catapult projectile does not start on the ground, lands on the ground, but it starts in the catapult. So we're going to imagine how high it is above the ground when it's in the catapult. That's why you can put 1 or 2 or even 3 or 4 inches if your catapult is higher. That's where the projectile starts, in the catapult, which is above the ground. So we're going to take these 3 points and plug them in. So this is the part, step 4, where version B is a little bit different from version A. Version B has you solving to find the factored form of our equation. And so we are going to start off by using the x-intercept. And so we're going to take this 126 and plug that in for our h value, and that's going to end up right here. Over here it says plug in -1 for your k. If we imagine the other x-intercept, that's going to be just barely on the negative side of the x-axis, and so that's why we're taking and plugging in a -1 right here. we need one more point to be able to identify the shape of our parabola. We know the two x-intercepts, we just plug those in. And we also need to use the vertex. So there's an x-coordinate of the vertex, that's in the front here, and we're going to plug that in for x right here and here. So we end up with those numbers right there and there. And then we can also take the y-coordinate of the vertex. There's our y in our equation, so we're going to plug that number in place of y. So now we've got it so that there's only one variable. A is the only number. We started with a whole bunch of numbers in there, and we got it down to only A. And so we're going to do a little bit of math to simplify what's going on over here. And then we can finally start isolating the A value, like it says, isolate the A value. Let's see here, kind of clean things up, and it says, so we just follow our order of operations first. We see two numbers that have, or two sets of parentheses that have just numbers, no variables inside them. So we can actually combine what's inside of those. The first one, we have 63 minus 121 will give us a negative 63. So you should end up with a negative number. Your numbers will be different, but it should be negative in that first parentheses. And then, remember we have two negatives in a row here. So what that's really talking about is a plus. So you should have plus 1. So whatever number you plugged in for the x, plus 1, will give you your second parentheses. So we've done what's inside the parentheses. Following order of operations, we don't have any exponents to worry about. Next, we would worry about multiplication and division. It does look like we have some multiplication. So we can take those two numbers and multiply them together. A negative times a positive gives us a negative. And so we end up with those two numbers multiplied together. So now we only have A being multiplied by this one negative number here. So we need to get that A all the way by itself. And so it's being multiplied. We're going to use the opposite of multiplication. So you can go ahead and draw a division bar underneath both sides because we got to keep it equal. Do the same thing to both sides. And you're going to take this number and divide it by itself. And divide the other side over here. Anything divided by itself creates a 1. 1 times A is just A, so our A is now all by itself. And so long as we do this division, on the other side, we'll know what A is equal to. Positive divided by negative, you should get a negative number. The A value goes in the very front, so that's our slope. We want our U shape to be upside down. Putting that negative in front will do that. And then dividing a smaller number by a larger number should give you a very small number for your A value. So in finally writing it in factored form, we're going to take that A value and plug it in right here. And then the H and K values that we initially plugged in are also going to go in there. So kind of follow this arrow backwards. And what it shows is that we take that original equation that we started with, this guy right here, and we pretty much just copy it, except we're going to take that new A value and plug it in. And that'll get us the final equation on this side of the paper. That's the equation you're going to start with on the other side of the paper. I'll go ahead and split my video up, and we'll do the second side on the second video.